Hey guys, welcome to this session on observability with Ballerina. So what Nathan and myself would be doing is we'll go through the general observability concepts, and then we'll see how observability is done in Ballerina, and also how Honeycomb also plugs into the picture on working with observability features. So first of all, the obvious question. So what is observability? So basically, observability is figuring out the internal state of your system by looking at the external outputs. So that's basically it. So it's the ability to understand the internal system behavior by using the features that are there. So observability is mainly done with instrumentation. So there are three ways of doing this. So we call it the three pillars of observability. So those are metrics, tracing, and logging. So metrics, basically those are aggregatable information, and tracing is basically to trace a single request and request level information basically. And logging is basically collecting individual events that are there in the system. If something like, as a snapshot, like if something happens, you log it. So it's individual system events we note it as, do as logging. Okay, so we'll first talk about metrics. In metrics, we'll mainly focus on like in service level metrics. So in that, we talk about the 4 golden signals, as they say. So this is popularized by the Google SRE book, and they talk about latency, saturation, traffic, and error. So so latency means basically for each in your microservice services, each individual request, how much time it takes to serve a request. So it's an important metric. So it basically says how well the service is working, how it's behaving, if it's running in a timely manner, and so on. So latency. And saturation is basically how the system resources are used. Like that's mainly CPU, I/O, memory, and so on. So because if a service is saturated in the whole system, if it's taking too much of resources, that can be a problem. So you have to keep an eye on that also. And then traffic is basically how much requests that are coming into the system, like the TPS, like how frequently the services are being invoked and so on. And then obviously error means how frequently the service is throwing errors. So if it's like most of the time, for a bigger percentage, if the service is throwing errors, then that means there's a problem. So likewise, you have to track that too. So so these 4 metrics are very important when you have a request response system. So mainly for services. And then let's go through tracing. So tracing is basically analyzing individual transaction flows. So this is when you have multiple components in your system, multiple nodes, doing different things like databases, other application servers, and so on. And when requests are flowing through this system, these systems will be emitting their own events. So in a system like that, what we do is we basically emit these events that in a correlatable manner. So then at the end, we can group these events together and create a single trace for each transaction. And these can be analyzed later because you have now grouped events for each individual trace, basically. So in that way, it's very easy to debug a system, see what has gone wrong, drill into a single request, and so on. So it becomes very easy to go to the minute details and understand what's happening. And then the other aspect is logging. So that's, again, as I said, it's recording standalone events in the system. So if something happens, you just say, okay, this happened, and you just record that. So especially when you talk about microservices, containers, and so on, you need a centralized and an externalized log storage. So because you can't no longer just have it in the local file system and store in like locally, but you need an external thing to collect the logs and index them. And the other thing is, after that, to be for the logs to be useful, you should be able to search the logs as well. So this is where the querying capabilities come into the picture. So the early index events, the logs, you should be able to search via regular expressions and other special query languages like in Solar, Lucene, and so on. They have their own query languages. So it becomes very important when you want to do something meaningful. And so then we come to, so that's a rough overview of all the observability features. So now we are coming to observing Ballerina. So what we have done. So Ballerina is observable by default. So that means how we have designed and architected the languages and the runtime. The users don't have to do anything extra to have the observability features. That means the most obvious aspects are given through the runtime itself and the language. That means rather than people using another library and pumping out the events to saying, okay, I'm doing this and that, we automatically emit this information from the runtime. So let's see in what stages we do that. So the most often used things are the services and the client connectors. So those have the observability features built in. So when you are using, for example, things like HTTP services, their clients and so on, we automatically emit this information like the metrics, the tracing information, and so on. So if you, for example, if you have a microservice, set of microservices which talk one service to another service, we automatically emit the metrics information, tracing the correlation data, and so on automatically. So you don't have to do anything extra to get that, get those features working. And also other connectors, such as the database connectors. For example, we have several databases for SQL, Mongo, Cassandra, and so on. They also automatically, when you are using it, emit these events. So especially in tracing scenarios and so on, those become valuable. Like then you can later on, when you debug the flows, you can see, okay, what queries are executing, when did they fail, and so on and so on. So, so most of the connectors are observable by default as well. And also another thing is, if you have any custom scenarios to be like tracked also, we also have a user API from Ballerina itself. So this is available in the latest release 0.980. So you can use the user API also if there are any scenarios that are not supported by default. So then let's look at the directly supported technologies when it comes to like tools and the basically observability servers and so on that are supported. So for metrics collection, we support Prometheus for storing and for the time series processing like the functionality, and of course Honeycomb. Then tracing, we basically have adapted the open tracing standard. So any open tracing compatible trace is supported also with Ballerina. And we by default basically ships Jaeger with Ballerina, so you can also plug in other providers as well. For logging, of course, we can just use the flat files, or we also support the ELK stack as well. And visualization, the out-of-the-box capabilities are using Grafana dashboards. So those we also ship with the product. So basically, you can get from the Grafana their website, like our dashboards are published there. You can get them and install, and you can right away visualize the stats we generate. So that's basically how the Ballerina, the observability overview. We'll look at some of the Ballerina Metrics in action. So you can see the dashboard we have created for the HTTP service monitoring. So we track things like the requests, the different percentiles for the service request times, and so on. And also tracing views as well. So similar stats for the distributed clients as well. And another view of the data connector support we have with the, here we have the SQL connector. And also another thing is in the Ballerina, so Ballerina is based on a VM technology, so the VM scheduler stats are also exposed if you are interested. So you can see how many workers are in active, blocked, and so on. So those stats are also exposed to be viewed in a dashboard. And of course, Ballerina Logging. So we mainly use the ELK stack. So we have some guides on how to configure and some dashboards on how to work with that. So now let's go into Ballerina tracing. So this section basically will be done by Nathan. So he's from Honeycomb. He'll be basically moving forward with the presentation from here. So. Okay.
Hi everyone, my name is Nathan LeClaire and I'm a solutions engineer at Honeycomb.io. What we are is we're an observability startup, and we provide a product that lets you ingest a lot of data in about what's happening in your applications and infrastructure. Then you can query it later on to solve problems. We really think that observability is very important for being able to deploy faster and with more confidence. And we're entering into a world where there's so much explosive complexity that tools like, for instance, distributed tracing, which I'm going to talk to you about our implementation of today, are becoming increasingly important. So just a few words on what is Honeycomb distributed tracing. A lot of people today are having an architecture where what ends up happening is you maybe start out with one monolithic service, and then over time you split it out into more and more components, and things are happening over the network to communicate between various parts of what seems to the outside world to be one cohesive application, but actually is composed of a bunch of different pieces and services talking to each other. And with distributed tracing, which is an evolution of sort of a variety of lines of thought, originally starting at places like Google, you can actually visualize a waterfall type diagram like you see here that shows you where are slow things happening in your architecture, where are problems happening in your architecture, and just really let you get a really nice granular view into the state of the world in production. And it's sort of similar if you're familiar with using browser tools for debugging. You might be able to see latency and the way that things happen over time. You can visualize how patterns are happening concurrently versus in serial. And it's a really powerful tool that you can use sort of as an extension of the native Honeycomb querying functionality. And one thing that's interesting about the Honeycomb implementation is that in traditional tracing, which you're going to see sort of a small example of in the deck, usually what you'll have is a span for each network call. So you'll be able to see things that are happening over the network, method calls that are being made. But with Honeycomb, it's actually a little bit more wide open. And if you set the sort of magic tracing fields on events that you're sending into Honeycomb, you can get tracing for things like Lambda executions, right? We just saw a presentation on serverless. And so in this kind of new and distributed future where you have all this weird asynchronous execution of lambdas and that kind of thing, you actually want to be able to get visibility into that. And so what we spend a little bit of time on is I actually tested out the Ballerina out-of-the-box tracing functionality using their Zipkin exporter. So Zipkin, in case you're not familiar, is an open source implementation of the open tracing protocol, right? A lot of people wanted to sort of start establishing standards around tracing so that we're not actually all reinventing the wheel all the time. And Zipkin is an implementation of that open tracing protocol that emerged as a result of that. And Ballerina will actually expose Zipkin data from your services by default. So if you're running Zipkin, or in this case, if you're running the Honeycomb open tracing proxy, which is a little program that we wrote that sort of pretends to be Zipkin and then forwards those spans onto Honeycomb for querying, then you can actually use this default exported data to send right along to Honeycomb. So I want to tell you a brief tale of two services. It was the best of times, it was the worst of times, it was the summer of microservices, and it was the winter of impossible distributed problems. So I had not really touched Ballerina at all until very recently, and I whipped up a couple of little services based on the Getting Started Hello World program, for instance, which is pretty much what you see here. And this is the back service where if you hit it, it will give you a text response back saying hello world. And then let's say that we add another service into our infrastructure that basically will forward requests to that backend service. And just like how there's a saying about how I decided to use regular expressions because I had a problem and now I have two problems, microservices are kind of like that except exponential. So I had a problem, so I decided to add another microservice. Really what happens is you end up with n squared problems where n is the number of microservices and probably even more exponentially increasing things that could go wrong. So I took a little bit of time to put together this program, which I'll spare you going over all the little details, but essentially it listens for requests, and when it receives a request, it will call out to this first program that we saw, and then it will forward back to the user what this program says, which in this case is just hello world. And if you want to rig up tracing and actually get the visualizations and kind of information and observability that I was talking about, you have a lot of different options. And the way that tracing historically is done might involve copious amounts of drinking whiskey, because you're sort of very frustrated because there's all of these magic headers that you have to do, right? It's not really easy. Every stage of tracing, you have to actually start a timer, create a new span, somehow get the parent span of the thing that called you, and then kind of collect all of this data together and forward it along the network, and also make sure that you forward it to Zipkin or whatever you're using to take in the tracing data. So it might drive you to drink if you're doing this sort of the normal vanilla way. Or you could just use Ballerina, which will export all of the Zipkin data by default. And so that's exactly what I've done in my example here. I'm sure the Ballerina folks will be happy to provide you with these sort of getting started steps, but all I had to do was copy a few jar files into my local Ballerina library directory and run the Honeycomb open tracing proxy, and then just by hitting the app without adding any code, right? Instead of the kind of reams of tracing code that you'll sometimes see if you're using the default Zipkin clients and that kind of thing, there's no tracing specific code in here. So how many lines of code did we have to add in? We didn't have to add in any. And so what you get in Honeycomb is, in addition to the default Honeycomb query engine, which is very powerful and lets you query over so-called high cardinality data like user ID or team ID and things that are traditionally very difficult to track with metrics, you can actually use all of that power of Honeycomb querying and then pop over to a trace view like you see here. And even just in that really simple example, I found out something interesting about Ballerina, which is that it actually appears to be using this HTTP caching client. So you can see in the second step in the tree here that the service name field that has been filled out in the event is Ballerina HTTP caching clients. And as we all know, caching is something that can go very, very poorly in production. I mean, obviously it's vital, right? You have to have caches to run any sort of service that performs well. But it's something that can really be the cause of like nefarious errors that are impossible to track down. So obviously, in addition to things like DNS, you should always be suspicious of your caches. And so I thought it was really interesting that this out-of-the-box default illumination was possible with Ballerina. And so I do think that one thing that's really interesting is in Honeycomb, you can have spans that are arbitrary. They're not necessarily tied to the network level. And so if, for instance, you had a method that you wanted to track the performance of, with the out-of-the-box Ballerina stuff, it's not necessarily possible, but you can actually have subspans that go beyond just network boundaries and break things down even further. So usually, traditionally, you'll have one network hop for the steps in a trace. But what we're sort of trying to do in Honeycomb is really push the envelope and make it so that you can actually do in-process tracing as well as just looking at the flow of things over the network. And so I did want to just take a little bit of a moment to reflect on what would be maybe next in this type of integration. I think it's absolutely fantastic that the Ballerina folks are really wanting to move things forward, because to do tracing in particular, it's such a huge pain to set all of this stuff up yourself. You have to be forwarding along request headers and managing timers and this kind of thing. And Zipkin, for instance, is very notoriously difficult to get started with. The full power of Honeycomb is unlocked by really wide events like this one that you see here. It's just a JSON blob describing the properties of an HTTP request. And what's nice in Honeycomb is that because we have this flexible columnar storage, you can query over all of the raw data and go look at them in very granular detail, just like you would with a log, as well as zooming out and seeing these high-level trends and visualizations of the system's activity that you don't necessarily get with other tools. So I did just want to have a quick, somewhat whimsical meditation that perhaps columns are the fourth pillar of observability. And that is a bit of a play on words, in case you're scratching your head, wondering if I'm just trying to be funny. I am. But I'm also just wanted to just quickly touch on the Honeycomb event model, because it is very unique, and a lot of the areas where metrics break down, they aggregate data together and you lose that rich contextual information. You might know that the 95th percentile of users are seeing a spike in latency on this endpoint, but then to go and dig into more detail, traditionally the answer has been to go look at the logs, which is sort of a way zoomed in level of granularity versus being able to flexibly and fluidly move through the system. So that's a bit on tracing and a bit on Honeycomb's data model. If you want to try Honeycomb, you don't need to sign up for an account. We just shipped play.honeycomb.io, which is an actual sandbox with real data from an outage that we had, with a tutorial that will walk you through your sort of first steps of getting started. So shameless plug, play.honeycomb.io, you can go try it. I'm in sales. If you want to talk to me more, sign up for a trial and get on the phone with us. And now I think we're going to take some questions and answers. Thank you guys so much for listening.